Hi friends, I am Saro, V2 Oscar Bravo Romeo. This video recording Wolf Transceiver, one of my friend UA3 REUO, Romeo Echo Oscar, developed this lovely project. It is very beautiful DUC and DCC transceiver. Today I am going to briefly explain the radio, how it's designed and how it's working. So first I'll start one by one. Yeah, this is the transceiver with a 7-inch screen with the limit buttons and very lovely waterfall screen and very less controls. That is the beauty of the Wolf transceiver. I made it in India, 15 members for the group build. So that group build we struggled a lot, get the materials and making the SMD soldering, and after soldering the QC everything. It's a very painful job. The project started last December. After 6 months I completed the first radio and started using, and now there are 7 peoples are using now. Other peoples yet to make the transceiver. So this is the group build I made. So one by one we are making. In India there is 15 members we are making now. So I'll go to the brief explanation now. Okay. Yeah, this is my logo, and now I started the slide, so I'll start in the beginning. So first of all, yeah, I started making the 15 boards with the help of JLC PCP. They made the PCP for me, and after that I made a SMD soldering work there in the factory. After that I'll started a workshop for our group members. First, since you seen what it is, that is the workshop day, taken the photographs. I thank all my friends joined on my team. You seen the peoples who are there on the photos. So one by one I'll start explain now. This is the front display board, which what you are seeing now. The front display board has the DC controller also. In the back side, this is the back side, and the front side will be the display. Yeah, I explain one by one. So this is the DC input, and this is the controller, and this is the fuse, and the next two connector is DC output for motherboard and PA board. This is the DC to DC converter, and this is for encoder, and this is for the MMC, memory card. We can use the memory card to store all the user data and CW messages and beacons, everything. And also the firmware we can upgrade with the memory card for STM only. So this is the back side. It is very beautiful design what made by Uniform Alpha 3 Romeo Echo Oscar. It's a very good design and so many productions. And this is the fuse and this is for the Wi-Fi. Wi-Fi we can the module around 150 rupees cost. We can plug it here. After plugging the Wi-Fi module, we can connect through the internet. That Wi-Fi will work for synchronize the time and getting the firmware upgrade messages from the server, and also the cat control. Cat control also possible with the Wi-Fi. So this is very nice design. And then next I'll explain the beauty of the 7-inch Wolf transceiver. This is the board. What you seen is the 7-inch screen board. So one by one I explain. So in the back side, yeah. So the only connectivity between this board and other boards. This is the controller, main controller for this is mic connector. We have the small PCB to solder the RJ45 connector here to use the 8-pin mic. So the mic we are using MH48. It is the standard microphone. It's sounding very good. Maybe not all. Maybe you listened me on the HF bands. So this is the front side. Only 3 controllers. One for AF control, another one for secondary encoder in the middle one, and the left one is the volume. So this is the 3 controllers and switches, and the display, that is for display slot. Just we have to plug the display and solder the pins, and that's all. This is the only for display board we called in the project. This is display board. So very nice, very less work, not so hard. So now in my hand this is the main board, that is the main FPGA processor. That is a superior processor. This is not used in any radio, and in the top one what I am touching is the DAC, and next one is the mixer. So this is the receiver part, and directly receiving the signals from the antenna, and goes to the microprocessor, and it is all digital work converted in the analog. So this is the RX part. That is RX 4:1 mixer, and the mixer to the small amplifier then comes to this ADC. Sorry. Yeah, okay. So next, that is for temperature controller. If the temperature rise, the radio will automatically shut down. So next is the bottom is the DAC, the DAC called TX. So TX purpose, we made it on the that is RX. This is RX section. This is the TX section. So TX section we have another methods. This is called DC to DC down converter. So the DC to DC down converter and filters designed for using the HF transceiver without any DC noise. So this is a special DC to DC converter, and if it is failure we can use locally, but there is the noise on the higher bands. But in this, if we use the original DC to DC, there is no issues at all. So next is the STM. This is the STM control for the analog to digital and display controller, everything controlled by the STM. And yeah, that is the STM32 we used. And this is the audio codec, audio analog to digital conversion, audio codec IC. So in this, it is very lovely design. In the back side, this is the audio output IC. We have to connect the speaker and headphones for the audio output, and all the connectors there, and all productions also there. There is no problem at all. What I am touching now is the USB controller. This USB controller is the very special USB controller. It can be control the CAT control and audio, especially IQ output we can take. Maybe you people know what is the IQ output. No need of any other conversion. Directly we can connect the USB cable and control the CAT control plus the IQ also. IQ we can use it with another SDR software to monitor the entire spectrum. But this is 7 inches screen, so no need of computer to use the IQ, and everything in the software having the radio standalone. So that's why, but all the future is there. We can use it in all. This is the headphone output socket, and next one is the the total production. All the input we have the production, and the connectors, headphone and CW key and audio out and audio in, all is there. Then in the back side there is the memory battery. Memory mean the CMOS battery. It's managing the clock timings and the user settings. So that purpose, that is the memory battery, we have to solder the um, uh, socket first, and battery we have to connect. Why? Because the batteries will drain 1 or 2 years. So if we use the socket, we can replace the battery very easily. If solder the battery, that is too hard to replace. So this is very simple design, and this is the main motherboard where nothing there on the other things. There is no IF, nothing. All is directly conversion called uh, DUC and DCC. So direct up conversion and direct down conversion. In between there is no IF section, nothing. And only some of the critical part what I called is the transformers 1:1 and 4:1. In the input AD 4-61 is the input transformer, that is 4:1, and in the bottom for the output there is two transformers. One is 1:1 and 1:1+1. That is for the biasing of the driver IC. So this is very simple, and yeah, in the bottom, in the top, what you seen is the RX, and in the bottom this is the TX area. One is RX, one is TX. That is separated everything. So one by one I explain, my dear friends, because this video I made it on my workshop day. So that's why there is not synchronize everything, but major part I will cover. That IC what I am touching is the amplifier IC. So that amplifier IC required the biasing. So there we used the 1:1+1 transformer. And another one is 1:1 normal. That what I am touching is the 1:1 normal transformer. This is all SMD, so little complication to solder, because if you overheat that strings will get too hot and melting. If melted, that functioning will not work. And yeah, next the DC to DC down converter, that is connected from the display board. The power supply comes from the display board, and this all filterings, we used the tantalum capacitors for the low noise. So that's why very less components. So next I'll explain next. In the workshop day, I explained many things which I forgot now. So important things only I am going to explain now today. So I'm waiting for the video to turn the back side. Okay. Now That is called EEPROM for the FPGA. And this two is the programming part. One is for FPGA, one is for STM. The programming part for external. That EEPROM is control for the FPGA. FPGA EEPROM. All the FPGA firmware will store there with the EEPROM, because the CPU don't have any memory part, so the FPGA program will store in the EEPROM. That EEPROM not soldered now, because this is the workshop time. We are started making one by one. This all we made it on the workshop day. So after this, I'll show you some slide shows how the PCB is made and QC done by me, like that. So I started the video immediate. That's why it's not possible to know. So after completing this main board, I'll show you the slides for the PCB production. What next? Okay, I'll wait for the video to end the main board. There is lot of explanation that day, because people are behind me, in front of me. They asked so many questions, and I explained one by one. So now I am joining with you with the video, so there is no questions. So no answers. So what it is, I explain one by one. In the back side now, I show you one by one. In the left side, there is the diodes, all the protection diodes that will not harm from any outside interference. So the protection they designed for the protection diodes. If any voltages and anything, that will cut down with the diodes. So that is audio IC, output IC, and that is the another EEPROM, which is for the STM. That is the EEPROM for STM basic booting. So that is very important memory area, and that is for connecting to the display board, from main board to display board connector. It is very critical to solder that. People know how to solder it. It is very difficult. By hand it is not possible, but need a knowledge about the material and SMD reverse skill. So that is the important thing. If it is 45 pins, 45 pins in the connector. So next will be, I'll show you how to connect it. All other backside ICs are only regulator ICs, and that is the EEPROM, controller of entire system. So that's all in the main board, and this is called, this what I am touching is the audio out for speaker output, and this is the stereo one. That is the important thing forgot to say. The stereo speaker, we can use it two speakers, very lovely audio we can listen in the both speakers. All the radios has only one speaker. This is the dual speaker, and also the dual speaker we can use it later on for dual receive, one for other band, one for another band. So that is the thing they designed for dual stereo speakers. That is for microphone input, which is from the display board. And this is for audio out, which is going to connect it external audio and uh, uh, sorry, audio output. And waiting for the next part. This all audio input, headphone and output, also the CW key. This all very beautiful quality connectors, and I'll explain how we struggle to get all the components in India. Later on, one by one, I'll tell you. So this is 1 hour video. Don't miss it. It is very lot of informations I sharing with you from this video. So that is the speaker output. I'm not used the original audio because there is another conversation in front of my group members, asked the questions and explained. So the same video I am using here because I don't have time to make a new video. So I used the workshop video here to give the demonstration here for LARC. I forgot one thing. I'm sorry. First of all, I thank LARC for always encouraging me to make new projects, especially the President Sasi and Farhan and our good friend Thomas and Amarendra. These all the guys always encouraging me to do something. In every time I am coming here with new things. So last year also I am unable to join because of my son marriage. Now I am having some health issues, so I am joining with you with the video. So thanks LARC guys again. So that is the crystal. It is 1 and 2.88 megahertz crystal. That is for the FPGA, and another one in the backside, that is 13.88 megahertz crystals. That numbers, it can be vary because I forgot so many things. It's did by long back. The exact frequencies of the clock you can download it in the UA3 REO block or GetCoff. You can download it and see the entire schematic. All is open source. That is 8 megahertz normal oscillator. That is 32.88 megahertz special type clock. So this is the important things. the clocks. Totally one, two, three, four clock oscillator is there. So sorry for the background noise. It's a morning time. They are wake up now. Okay. So I'll wait. What is the next? Another important thing is the tantalum capacitors. That footprint capacitors not available in India. Anyhow, I managed some higher footprint capacitors that our doctor HMI Garu helped me to get from Hyderabad. And other all the capacitors, tantalum capacitors, we get very easily locally, because these things are I am not ordered abroad because of the weight. If I ordered these things, that project will be costing, again it is going high. So that's all for the motherboard, I think. Let me see, wait for the video to complete. That is the potential meter for the fan, which is for the FPGA will get overheat, so we have to use a fan. That fan FPGA, and for the RX part we need a fan. So that is the fan controller. Only one potential meter on the entire board. That's called only for fan control, fan speed control. That's all. So I'll take some water. Yeah, thank you. Sorry. That is the thing what I am touching now. That is going to the PA board, power amplifier board, interconnectivity line. I'll explain that things later on. Only this 10 pin connector we used for the connectivity. Two DC cable, one is positive and negative, and this 10 pin will control. This is now comes with the RF board. This is the RF board what you are saying now, and I'll explain one by one. Yeah, there is two antenna connectors. One is antenna 1 and one is antenna 2. In the beauty of the relays, I am really so confused in the first time before saying the relay, because this will control antenna A and B, and also TX and RX. So it is very beautiful relay they used. Antenna AB selection, also the antenna 1 and 2 changeover with the TX and RX also. It's a very beautiful design. You guys can download the entire schematic in the website, UA3REO website. All is open source. You can download it and see the schematic. You can get surprise. And next one I'll explain. Yeah, that is the important part. Search protection. It is called surge protection. That is for the RX section. Only RX section they used the surge protection material. Whenever there is the static or lightning, that will protect the radio. And this one is the LNA, low noise amplifier, for using VHF and UHF and HF also, but HF not required. And the direct signal also very fine, and this is especially for VHF and UHF, because this transceiver covers 0 to 850 megahertz. So that higher frequencies we required the LNA. What I am touching is the static protection diode. There is the static protection diode in the this is the alternator. This is the built-in programmable alternator. By the software we can control the alternation levels from 0 to 30 dBm in the RX part. So that is called the alternator IC. And another things, that is going to the ADC. That ADC what we seen before in the radio. This is LPF, for the broadband LPF used in the backside. There is lot of things I learned in this project. I am really very happy to did this job and take the pain. It's a very informative project, and I learned many things. And that is the RX line, and this all PPF bandpass filters. Each band we have the filters from VHF to 160 meter. So all BPF completely. Thus all switching can made by the microprocessor and the software. And next part, that is completely RX part. This is fully TX part. This is called DAC. So the DAC input comes here, and again the 1:1 transformer, and that 1:1 transformer can make the isolation. After that, that is comes to the LDMOS. There is two LDMOS used. This is a board called 20 watt version, 20 watt in the HF and 7 watt in the VHF and UHF. So, and from main board to DAC comes here, and these two LDMOS. What I am showing is broadband LDMOS. It is up to it is designed for 850 MHz, but we can use it with the HF and VHF also. So very nice LDMOS. Some of the components not soldered, and the coils are not winded and installed. This is the homework I'll given my group members to do the transformer winding to learn how to make the output transformer. So that's why the output transformers are not there, and also the tandem match transformers not installed now. After later on, you can see some another video. It is completely soldered and tested everything. In between I am taking some rest. I am sorry for that, because this is a continuous video. I am giving the voiceover, so there is the not synchronized. I am planning to come there and explaining directly everything. Unfortunately, not possible to join with you guys. From the LD mass and one-to-one, that is the final output transformer from the LD mass. That too is the DC coupling for each LD mass. Like a dub mass I am doing. Yeah, backside nothing is there, just only one controller for the LNA, nothing else in the backside. The backside connector can connect to the main board, what we seen earlier. What I am touching is the another transformer, balancing transformer, and next is the 70 megahertz LPF. Now we are not using the 70 megahertz, but in the design there is the 70 megahertz LPF. I am not skipped that one, also I installed. That is the tandem match. That is small tandem match can measure the output and reverse reading. So that is the purpose the tandem match is there. That can goes to the processor STM, then the processor, then we can get it on the display. This is the backside yeah. And there is many thing I explained in the workshop time. This is the connector which is going to the main board. From main board to connect the PA board. That is the connector. Because we are going to make the sandwich type one by one the boards fitting, so that purpose we have the connectors in the back side. Over the people attended that workshop, they asked so many questions and I explained many things. Here today it is not possible to explain like that. If you peoples have any doubts, you can ping me directly. I can explain. All you knows my mobile number and email ID. If you have any doubts, you can contact me directly. I can briefly explain if you have doubt. And this is the important thing. We are going to connect it the ALC and PTT out and the band data for using external amplifier on that pin. So that's all from this RF board. Now I am going to show you how to assemble the display to the display board. It's all and just plug it and make the screws. Then we have to solder it on the back side, the display soldering. I don't want fast forward it because there is lot of informations. You can see if you are going to assemble it yourself, you can do it very easily. That will help this video. So after 4 screws, that LCD is fixed on the display board. Already there is the encoder fixed and mic connector fixed. Now I am going to the software part. Now all the front board were completed and main board connected. So I am going to first what I put the boot pin I connected already, and now I insert the USB cable to the connector, the power button pressed, and there is nothing on the display, only white display will come without software. Now the STM program is started. You can see the programming methods. Just I connected the board. It is easily connected. There is no error on the main board. I am selecting the STM bin file to program the STM32. So file selected and started the programming. In this programming, there is in the bottom there is the line we can't see in the smaller laptop. So we can see. So this is the first programming part of the STM. After completing the assembling to main board and the display board, first we did the programming for STM32. After STM32, it is only white display. That boot jumper is removed and power removed. Now I am going to program the FPGA. After FPGA program only we can get all the display and other things. In the FPGA programming we need the blaster. Blaster mean that is the called interface. Just powered on. Now the power is the stable. I am going to run the software in the FPGA programming software. I did so many homework on this project. I am really happy. First of all, I thanks the team members who joined with me for the beautiful project and invested blindly, and all are happy now. So this I am going to programming the FPGA. This all I learned myself because I have knowledge through the software and hardware programmings. So for me it is very easy. So others can, if you have doubt, you can contact me anytime. So in the top left, top right, you can see the programming part one by one. The programming is 100% success, and there is the blank check now. There is a progress on the right top. Something not visible because of the logos. Wow, the all software loaded, the display is on now, and the default settings loading. Now I have to power up the radio. This will not boot immediate, so I have to power off and power on again to normal boot. Programming is done, completed. Power off now, powered off, and I am removing the USB blaster. Now I am going to power on. In the workshop time, default settings. Wow, the displays came and the radio started working. In the workshop time, my friends are very much happy to see that first radio powered on. And next, this is the RX part. Sorry, I'll put the audio also there. You can listen. There is some clippings in the audio because in the video rendering there is some kind of thing. I did all this job myself, so I am not a professional video editor. Excuse me. This is the first FM stations we received. It's a very beautiful quality of waterfall and audio, the stereo audio we received. Here in the video some if you have the radio in your hand,
அட்டகாசமாய் அமர்கலமாய் ரசிகர்கள் கொண்டாடிய போதும் அமைதி புன்னகை செய்யும் ஆசை நாயகன்.
This I used my HF antenna. If I use the proper antenna, we can get still more quality signal. I enjoyed many things in this radio. Very huge display, the waterfalls and coloring. This is another part, JT FT8 standalone FT8 functioning. We tested on the workshop day. This is standalone, no need of any computer to work FT8 and other things. CW decoder and many things. You can get all the details in the UA3 REO blog and the website. My audios, if it is little low, please excuse me for that. Wow, this is the first 3D waterfall in the non-branded radio. In the branded radio, only few radios has this facility. But in the Wolf transceiver, I really like very much. And this is
For the followers for the Silicon City net. Q2 November Sierra Lima over.
HFRX.
For the followers for the Silicon City net. Q2 November Sierra Lima listening for.
This is I made a TX test with VO3 PCP. The first TX transmission.
Yeah, Roger Kannan. VO3 PCP, VO2
250 watt along
Roger
with
Kannan. நேற்றுக்கு ஈவினிங்லேருந்து நல்ல டிஸ்லிங் கண்ணன் நல்ல டிஸ்லிங் இருந்தது. இன்னும் அப்படியே கண்டினியூ ஆகுது. டிஸ்லிங் கண்டினியூ ஆகிட்டுருக்கு. மழை வந்து ஹெவி ரெயின் இல்லை. அதுதான் எங்கள் ரிப்போர்ட் கண்ணன். VO3 PCP, VO2 OBR.
This is VHF test. Again with the VO3 PCP. He is my neighbor here. This is the net of VO2 TCD.
Good morning to all stations on this frequency. We are coming in 5-9 through the equaling. WH here is bright sunny morning, 21 degrees starting. URU 73, VU3 PCP. This is VU2 EHR clear.
Romeo E3 PCP morning okay, good audio, final plus. Thank you for checking in and listening. URU 73, good at you okay. Any more sessions? So repeater please call now. VU3 PCP.
VO2 Oscar Bravo Romeo OBR.
Hey, money, sir. Any more? Money. Good morning, next hour, CCP Connect and OBR and all our friends in frequency. Dialect now, no traffic. QR country, 3PCP, and signing clear out.
First made in test for the VHF.
Morning, my excellent copy, final plus money, and I say, show you 70.
Local repeater.
Good day to you. V2 OBR, morning, sir. Audio is slow. Comment, sir, in traffic over.
Roger Kannan. Very good morning Kannan. Good morning Mani. Good morning all my friends. First time I am using the Wolf transceiver. Otherwise no traffic. QRU 7 PCP VU2 OBR.
V3 PCP morning, sir. Excel copy directly also full scale. Excel copy also level a little bit low. Otherwise everything is good. Thank you, sir, for checking and saying QRU 73. Good day to you.
Sorry, the video is over. Now I am going to make a slideshow. The slideshow I forgot to add the files. Please excuse me. Not this. And where it is. Yeah, this is the one. Please stand by, guys. I forgot where I keep the files. Maybe this. No. Please stand by. So if you guys have any questions, you can contact me directly. I am unable to give you a reply on here because this is a pre-recorded video I am explaining here. So if you have doubt, you can contact me anytime on the my Lima or in the WhatsApp. I always happy to uh, help all of you guys. Yeah, finally I found the video where it is, so I'll add that now. That is only for the video, photographs what I made for this project one by one, the photograph videos. Wait, again I forgot where it is. Desktop. Okay. Yeah, I found it. Yeah, you can see now. And this is the workshop day we taken the photographs. All the boards completed and tested also. That day we enjoyed much with all our guys. Wait, I'll this may be end of the display. One more I take. One more. Yeah. Here. Okay. Where it is? Here. I'll come back again another slide source. This is the workshop day. We taken too many photographs. Oh, again it is same. Sorry. So something I missed somewhere. I'm sorry, guys. I'll give you brief things in my next time because the video is too much time taken now. So thank you very much all. First of all, I thank LARC, the team, and all who monitoring in the venue and also the YouTube. So thank you very much all. This is Saro, V2 Oscar Bravo Romeo. 73 is all of you. See you later on in the next session. 73 is bye-bye.